Alright, in this video we're going to be going over some text analytics basics in R, and we will be answering some of these questions about what is text analytics, why should we consider doing text analytics, and how can I do text analytics. So we are all about text analytics. So first off, what is it? Very simply put, it's the process of converting unstructured data, text data, into meaningful data analysis to measure customer opinion, product reviews, or sentiment analysis. There's a lot of things that go into that. And so it is, like it says, converting unstructured data into meaningful insights. And that partly answers why we do it as well. Think about how much data out on the web is unstructured, and what that means is that it's not in a table, it's not nicely organized for us to do initial analysis on, and not in columns or rows or anything. That would be structured data, but unstructured data does not have any of that organization, and we want to take advantage of all that data that is out there that is unstructured, and we definitely don't want that data to go to waste, because there's a lot of value and there's a lot that you can do with unstructured data. So let's jump into how we might do this. Let me pull up the screen for you. Alright, so in this text analytics segment of our tutorials, we're going to be using these packages right up here. RDS, TK, Reader, Twitter, QDAP. I don't know how to say this one. I'm going to guess Syuzhet. Who knows? And ggplot2. So take some time and make sure you load those in. You have those installed. And what I usually do is, when I start a new script, I highlight it. And I'm on a Mac, so I press Command Enter. And as you can see down here, I just made sure all of these libraries are included in this project. And if you're curious about what any of these do, I'm not going to dive into all of them extensively, but as you can see, question mark and then the name of the package, and it'll bring up some interesting things that you can look at. See, this is an introduction, and you can go and learn all you want about it. This is for Reader, another one of the packages we're going to be using. And if we also, just for example, we do Twitter, let's do a double question mark. Brought up the documentation for Twitter, and we'll be going over that in a later video as well. But so you can learn all you want about these packages. I'm going to dive in, and we're going to learn how to really use this tool, use this principle of text analytics. So first off, you'll want to get some type of text file. And in this case, I simply picked a speech that was by Gandhi. I don't know what speech this was. I don't know anything about it. I just thought it would be interesting to come in and analyze it. So go ahead and get a document that you can analyze, and I put it in a folder within my project that says assets, so I know where I can access it. So once you've decided on what text file you're going to be using, go ahead and use read file and bring it on in. So read file is a function that comes from the Reader package, and basically it works really well with text files and reading them in just as they are naturally found. A lot of the other data import functions don't do as well with unstructured data, so this read file works really well, as you can see. So I'm gonna go ahead and click here and Command Enter, make that run, and then View. And as you can see, here we are. We have the speech here. So now that we have the speech and we are ready to analyze it. Let's go ahead and move forward and talk about polarity and sentiment. So polarity is a very simple concept. It's when something is either positive, negative, or neutral. And so it'll analyze a word or a sentence or a paragraph, whatever it might be, and it'll give it a polarity score. And that's either positive or negative points. And the way it does that is that it has a dictionary of words with certain scores already attached to them. And it just kind of it evaluates it with that. You could call it a bag of words or a dictionary. And sentiment analysis is very similar, except it is a little more broad than just positive or negative or neutral. It has various emotions, and we'll go ahead and see what those emotions are very soon. So what I did, I created a new variable called G scores. So for the Gandhi speech, scores. And I used a function that comes from this Syuzhet package, and we can look at it real quick. So it says get emotions and valence from NRC dictionary. So this is just one of the dictionaries available that has those sentiments attached to the different words in it. This one has 8 different emotions. And so let's go ahead and run that. Let's go ahead and look at what it brought up by just typing G-scores, Command Enter. So as you can see, it gave it a variety of points down here. Anger has 11, anticipation has 12, disgust 5, and it goes on and on. And as you can see over here has 37. This is the highest scored sentiment out of the whole document. So overall, this speech by Gandhi was very positive. I did some other analysis on different speeches that he had, and they vary quite a bit from sadness, uh, from anger with the government, and just with, each one of his speeches has kind of a different feel to it. So it was really interesting to look into that, and I would encourage you to do that if you have the time. So let's go ahead and look at what G-scores is by using class and passing the variable G-scores into it. Okay, so it's a data frame. That's good news because that means we can use it pretty easily. Now, if you noticed, before we move on, at the end of this sentiment, there's negative and positive. Now we already discussed that polarity is very much negative or positive or neutral. And so what we want to do, we kind of want to get these feelings, these emotions, separate from this polarity score. So what we're doing here, I created a variable called G_polarity, and what I'm doing is I'm going to go search through this data frame. And if you remember how to search through objects in R, this first this first number represents the rows before the comma, and after it represents the columns. So I'm saying go into G-scores and get the first row, but only get the things and the items in the last 2 columns. So first row, and if we go all the way over here, this is the 9th and 10th column within that. So we do that, and so we get G polarity back. Let's go ahead and look at that, make sure we got the right thing. Okay, so negative 20, positive 37. We're going to do the same with G sentiment. And the same thing, first row, and we are going to get the first 8 items, first 8 columns in that row. So there we go. Now let's look at it. Okay, so we have what we want. We've split those things up, and now we can move forward for further analysis. So let's go ahead and visualize the polarity. All of these numbers are important, and they can help us analyze things, but when we visualize the data, it makes it a whole lot easier to digest and derive meaningful insights out of them. So to begin, we're going to look at the class of G polarity. And this is a data frame. Now, normally this would be a good thing to have. Data frames are usually pretty helpful, but let's go ahead and look at if we tried to visualize it with a bar plot. Let's see what happens. So as you can see down here, we got an error. And the error says that the height must be a vector or a matrix. So we don't have a vector or a matrix right now, but it's easy to convert this data frame to one of those things. And in this case, we're going to turn it into a matrix. So we're going to overwrite that variable G polarity, and we're going to call this function data.matrix. And the parameters for this, you need to pass in G polarity, whatever you're changing, and you're going to use row names.force equals true. And what this does is, if you look up here at the data frame that we made earlier, well, in this case it's the polarity, so it's not that one, it is this one. And as you can see, there's negative and positive, and we want those labels to stay with them. Otherwise, they're just numbers and they don't have meaning anymore, and it'll be easy to forget which one is which, especially if we're doing a lot of analysis on a lot of different things. So row names.force equals true will preserve that negative and positive label for each one of those numbers. So we'll go ahead and run that. And just for fun, let's go ahead and, okay, so it's been turned into a matrix. And, from the untrained eye, if we just look at G polarity, it looks like it may not have changed, but it really did. And we know this because if we call bar plot right here and pass in G polarity, what we get over here is a score of the negative and the positive. So we can kind of see the relationship between the two a lot easier than we could when we were just using the numbers in their raw format down here in the console. So yes, it is a matrix. Let's go ahead and visualize the sentiment. We're going to take the same approach. Again, look at the class of G sentiment. It's a data frame, and usually that's okay, but in this case we want to put it into a graph, and most graphs need some type of vectorized or numeric data structure. So G sentiment, we're going to override it with data.matrix. We're going to pass it G sentiment, and we're going to call row names.force equals true, because we want to preserve anger, anticipation, disgust, fear. We want to preserve those labels with each one of those numbers. Let's go ahead and call that, and then we'll call bar plot once again. And as you can see, let's expand it out so the names show up. As you can see, we have visualized the scores for each one of these emotions within the document, within the speech that Gandhi gave. And what's interesting, we see trust is a big one, and right away, that's a huge insight that we can gain. And I don't know, let's say you're analyzing a product from online reviews, and you see a massive spike in trust, or you see a massive spike in anger. It's a lot easier to see now that it's visualized, and you can act, and you have that meaningful insight now that we've visualized it. So what we've done so far is that we've consumed the Gandhi speech file, and we have got the sentiment and the polarity from it, and we have visualized both of those things. And what we're going to do next is just something, just a little bit of a different way to analyze this text. And one of the functions that the package has, this package for the sake of me not knowing how to say it, I'll highlight it. This package is get sentences. And so you see right here, get sentences. And basically what it does, it just runs through the document and breaks up each sentence in its own observation in a data frame. So let's go ahead and see what that looks like. So we ran get sentences, and again, let's look at this, command enter. And as you can see, it just broke up each sentence. It's super simple. And the advantage of this is that now we can go ahead and look at this document on a little bit more of a detailed perspective. We can know which sentences had the most weight with which sentiment, and so to do that, we're going to use something called get sentiment, which is also in that same package. So I'm going to create a vector of get sentiment. And what you need when you call get sentiment is the speech or the text file that you're trying to analyze, and you're going to pass in the method. And I'll explain this a little bit later once we run it, and I'll explain what you can do differently there. So let's go ahead and run that. Look at this get sentiment and put it into the sentiment vector. And as you can see, it has scored all the different sentences with their different sentiments. Don't get tongue-tied saying all those things. But let's go ahead and take a look at a summary. Now, if you forgot, summary just gives us a good high-level overview of the distribution that we have in the data set. So this is really useful because all of these numbers up here that we get from the sentiment vector, it's hard to kind of conceptualize what the relationship is between all of those things. And so the summary function gives us an overview of that. And better yet, let's visualize that summary with box plot. Now the box plot is helpful because you can imagine if we're looking at a bell curve from an aerial perspective from up above, this is what it would look like. And what we can learn from this box plot is that primarily, if we look right here, the 0 mark is right here, and that is the median. But for the most part, it's skewed to be positive. So most of the sentiment in here is positive. And there is an outlier out here. It'd be interesting to figure out which was the most positive sentence in that whole paragraph. And we're going to look at that in just a second. But let's go back and look at this sentiment vector, get sentiment. And like I said, you can use different methods in here. Now, what does that mean? Well, let's look at the get sentiment function. And if we look here, get sentiment, pass in a character vector, the method, and if we look down here at method, we learn more about what it is and what you can do with it. So the options include all of these different dictionaries that we can pass in to have them score against it. So they all use their own type of scoring system for the sentiment analysis on each sentence. I'm not going to experiment with that right now, but feel free to go ahead and do that and know that that is an option. And one way that it has been done in the past is that you score all of them and you take the average and out of all of them, and that is your final score. But for our purposes, we are not going to go over that much. So let's move down here. Let's go back to the viewer plots. We see this outlier up here, and we wonder, okay, what is that outlier? Because that is an observation, that is one of the sentences that Gandhi had, and it was overwhelmingly positive. So let's go ahead and look, and let's answer this question of what was the most positive sentence in the whole paragraph. We can do that by using one of the functions called max sentiment vector, and max works on numeric vectors and just finds the biggest number and brings it back to you. So if we run that, 2.85. Awesome. Now, is that actually very helpful? Not really, because although we know what the number is, we don't know which sentence it is. So we're going to go ahead and make sure we can access that by changing sentence sentiment to a data frame. So now let's go ahead and look. Basically what we did here in line 103 that you see, we took two different vectors. We took the sentences that we split up back here with get sentences, and we took the sentiment vector. Before we ran this command to put it into a data frame, there were two separate vectors, and there are two different types, and so they couldn't exist together in a vector. So we have to put it into a data frame which allows multiple types to exist in the same data structure. So we went ahead and saved that in sentence sentiment. So you might consider finding a better name for that variable because it's really hard to say. But we are combining those two, and this is what we get. As you can see, each sentence is tied to each of the sentiments that it was scored with. Now what we could do is we could look through this document that we have in front of us, and we could find the highest. We can even filter it right here and say, oh, okay, that was the highest one. That is the most positive sentence that he had. But if you've got a massive document, you don't want to spend your time looking through all these things and doing it manually. You want to let the code do it for you. So one way we can do that is using this which.max. Now, in order to do this, you need to pass it the data frame or the data structure that you want to look at, and you have to say which column you want it to look at. And so if we look at sentiment vector, so this is the numeric part of that data frame. So we want to go through all of these and find the highest one. So which.max, we're going to run it, and it brings back 14. And we think like, what the heck is 14? We know there's nothing in here that got a score of 14. But what it actually brought back is an index, a location in the data frame that said, hey, this is where it exists. And so if we go here to see the view here, index number 14, it's like an ID. So now we know where it is, and we can pretty easily pull it out by creating a new variable called most positive. You can name it whatever you want, and we're going to say we're going to dig into the sentence sentiment data frame. And if you remember, we've used this a few times, but maybe not with this type of approach. We put numbers in here before. We put row, column, and that's how we'd search it. We'd usually say, okay, first row, third column. That's what we want to get. Now we can do that, or we can just call this right in the function. And so this will bring back a 14 for row 14. And don't forget to put the comma here, otherwise it won't run correctly, because you have to specify that you want, when you leave this blank, you're saying, I want everything from row 14. I want all of those columns. So we click that, run it, and let's go ahead and look at what we got. So this is his most positive sentence. And I would read through it, but I don't really want to right now. So go ahead and read through it, and you can tell me how positive you think it is. But let's go ahead and move on to word clouds. Now, I'm going to just tag this on to the end of this video because it's pretty simple. What you'll need is this collection of packages. And as you notice, we may already have some of these included in here. But it doesn't hurt to repeat them. It'll just tell you they are already there. Let's go ahead and include them. If we look at word cloud real quick, we can see that it will plot a word cloud, and you have tons of different options. So you can really customize a lot of this word cloud. So let's see what it looks like by passing it the Gandhi speech that we've been analyzing. So these are his most common words that he has said, and it just kind of clumps them together and gives you a good visualization of kind of what the whole speech was about. You know, he talked a lot about God and the law and the power. So this is really helpful once again in pulling meaningful insights out of data because you can visualize the results and you can answer your questions a lot quicker. So stay tuned for the next video. We're going to be going over some more things with text analytics, specifically with Twitter and using that R package.